Let's look at this example. We have triangle LMN. And the problem asks us to translate that x minus 1, y plus 7. Okay, so here's our rule. X minus 1 and y plus 7. Well, what does that mean? That means my x value is moving 1 unit to the left. Okay, so it's going in the negative direction from where it is. And my y value is going 7 units up. Remember, the y-axis is up and down, so this number moves it up or down. So if it's positive, it's moving it up. If it's negative, it's moving it down. And my x value is my x-axis, left and right. If it's negative, it's moving it left. If it's positive, it's moving it right. So because I have it on a grid, I can easily do this by counting over left 1 and up 7. But let's look at the points. Okay, so let's take point L. We have 2, negative 5. So point L is at 2, negative 5. Now again, you can take that point and go left 1 and up 7. Or we can use our rule here. We're going to subtract 1 from our x and add 7 to our y. So our L prime is going to turn into 2 minus 1 is 1, and negative 5 plus 7, that gives me a positive 2. So that's my new L. Let's see M. M is 2, negative 2. So 2, negative 2, I can move left 1 and up 7. I'm subtracting 1, that's left 1, and positive 7. So my M prime is 1, 5. And my last point, point M, is 4, negative 5 in my pre-image. 4, negative 5, and I move left 1 and up 7. So now my N prime in my image is 4 minus 1 is 3, and negative 5 and positive 7 is positive 2. So here you have your 3 points to your new triangle, L prime, N prime, N prime. So let's look at that image now using that pre-image triangle, and let's see the new triangle that we get. L prime, M prime, N prime. And you can see it's shifted over 1 unit to the left and 7 units up.
So here's a second one that we want to look at, just kind of going the other way. Figure FGHJ is translated using the rule, and they show you the rule there. What are the coordinates of the vertices of the new image? And they gave us some options here. So this means we take all the x coordinates and we move them to the left 3. Then we take those same points and move them up 4. So our h is negative 3, our k is 4, left 3, up 4. So G would go 1, 2, 3, 1, 2, 3, 4. So G would go to the point 0, 5. So we could drag this, we would. 0, 5. And let's see, H goes left 3, 1, 2, 3, up 4. So to the point 2, 2. J goes left 3 up to the point 0, negative 1. And then F should go 1, 2, 3, negative 2, 2.
Let's look back at the problem from the beginning of the lesson. We were asked to come up with definitions for translation, reflection, and rotation. let's look at translation first. Here we have a rectangle on the coordinate plane, and to keep track of our vertices, I'm going to go ahead and label them A, B, C, and D. So when we translate this rectangle, you want to think of the word slide. So we're going to slide this rectangle to a different location. And I'm going to go ahead and just slide it to the right. So this is an example of a translation. The object just moved to a different location. The object is the same shape and size, and the orientation did not change. So this is an example of a translation. Next, let's go over reflection. So reflection is when you flip an object over a line. Now it could be the x-axis, the y-axis, or it could be a diagonal line. So in this case, let's pretend we're reflecting our original shape, our original rectangle ABCD over the x-axis. So when I reflect it, the A is going to come down here. 1, 2, 3, 4, 5. It has to be the same distance from the line of reflection. Oops. So there's a rectangle that's reflected from our original rectangle. Okay, notice that the size and shape are the same, and the orientation is different this time. Okay, the A and the A prime are not in the same spot. The original A is at the top left corner, and if you notice, the A prime is the bottom left corner. So the orientation did change. Finally, let's go over rotation. So rotation is when you rotate an object. Now you need to know what you're rotating around. So in this case, let's rotate around the origin. And let's rotate, let's say 90 degrees clockwise. When I rotate 90 degrees clockwise, A is going to get turned. So we're going to go in this direction. So A is going to be right here. B is going to be here. D is going to be here. And C is going to stay where it's at. Let me use double prime. And there we go. We've rotated our original shape. Notice the size and shape are the same, but the orientation is different as well. In this lesson, you learned how to identify a rigid motion, and you learned how to read and map a translation.